Okay, let's start now. Online folks, I win.
Yeah, okay, sir. This
Yeah.
is Subramania.
Yeah. Let's try to recap what we discussed last week by answering these questions. Yeah. What are shape statistics? What are the statistics we have discussed so far with respect to the shape of the distribution, the shape of the data?
Symmetric and unsymmetric, is it?
Yeah, symmetric and unsymmetric. Which statistic we discussed about that? Skewness, right? And about the peak and flatness of the data, the kurtosis. Skewness and kurtosis are treated as shape statistic. Clear? If mean is greater than median, what is the shape of the distribution?
Positively skewed.
Positively skewed or
Left-tiled.
left-tailed or right-tailed?
Right-tiled, sorry, right-tiled.
Right-tailed, right? So when mean is greater than median, where will you have the mean? Is it in the peak or towards the right of the peak or left of the peak?
Right of the peak.
Mean will be towards the right of the peak because mean tends to get influenced by outliers or the extreme value. Outliers or the extreme values lies towards this tail area. Okay. And where does your median lies? Exactly in the peak. This is your median and this is mean. So in this situation, is mean is greater than median or lesser than median? Mean will be greater than median, right? Because as you move forward on the x-axis, you will have the increase in the values, right? So when the mean is greater than median, how does the shape of the distribution looks like? It's positively skewed, right? What feature does third moment business decision talk about? What is third moment of business decision? Skewness. What features it talks about? Symmetry or asymmetry existing in your data, right? So the skewness talks about symmetry or asymmetry that's there in your data. What feature or aspect does fourth moment business decision talk about?
Peakedness or flat.
Yeah, peakness or the flat that exists in your data. So if the data is, if you're seeing the peakness, high peak in your data, then how do you interpret that from the variance perspective? less variance, right? When there is a high peak and there is a tall peak in your data. So that means the data points that are there in your data set shares the less distance with its mean. What is the variance formula? What is the variance formula? Come on, guys, what happened?
Sum of x minus mean divided by n.
Summation of
X minus
x minus mu
mu square.
mu whole square
Yeah.
divided by
N or u. N. I think it is population n.
population size n. So effectively, if you look at measuring difference of each of the data point towards its mean in the numerator. So when the data distribution has got tall peak, that means the data is very much close towards its mean. Hence, the variance is lesser. You'll have a less variance when you have a tall peak. As opposed to that, if you have a flat peak in your data, then the data spread is far away from the mean, right? What a summary function gives you in R. Summary function give you the basic statistics information about the data. Mean, median, minimum value, maximum value, and first quartile, third quartile, right? What is IQR?
Interquartile range.
Interquartile range. How do you calculate IQR?
Q3 minus Q1 divided by 2.
Divided by 2. Where did you get 2 from?
Oh, okay.
Q3 minus Q1. The difference of
Q1.
your third quartile and the first quartile is nothing but the region that you take into consideration, understand about the distribution of the data. This region is called as interquartile range. What percentage of the data lies between Q3 and Q4?
25%.
Exactly. Okay. So Q3 and Q4, between Q3 and Q4, you'll have 25% of the data. Right? If the entire data is distributed into 2 halves, let's say this is your 100% of the data. Divide that into 2 halves. This is your 50%. This is the remaining 50%. How do you represent the exact midpoint between these 2 halves of the data? Which quartile will represent the exact half in between these 2 halves? Q2, right? The median. The median will represent the midpoint between these 2 halves. So this is Q1. This is Q3. This is lower extreme. And this is upper extreme. Here Q4 is nothing but the upper extreme. So 50% is already spread between Q1 and Q3. Right? And the remaining 50% will be spread equally above Q3 and below. When you spread 50% equally below Q1 and above Q3, the respective portion will be 25%. You'll have 25% of the data lies between Q3 and Q4. How do you identify outliers from the box plot in R? Which function did we use?
Out.
Out. Yes, exactly. Okay. The variable into which you saved the box plot results, $out. You see the outliers. Clear? What is the formula for skewness? What happened, guys? Not repeating it out.
X minus mu to the cube divided by n.
What is the starting notation?
Or sum of
With some, that is E, expected value.
okay.
K3, skewness can also be represented by K3 is equal to expected value of X minus mu
by sigma.
by sigma whole power
3.
3. Right? How can I represent the skewness in terms of standard normal distribution? Standardized values.
Z is equal.
How do you represent the standardized values?
X minus mu divided by sigma is standardized.
So what? How do you represent that?
Z is it Z standardized value?
Exactly. Standardized values are represented by Z. This can also be represented by GQ. Right? Z is nothing but X minus mu by sigma. Just give me a second. Sorry guys, there is too much of background noise. That's the reason I had to stop. Still continue. That's fine. Can't help. Shilpi, are you able to hear me now?
Yes, I can hear.
Okay. Okay, fine. Then what is the formula for kurtosis? Kurtosis can also be represented by K4. It's nothing but
Estimation key
expected value of
Unit minus 3.
x minus mu,
x mu divided by sigma
sigma
to the power of 4
to the power of 4 minus 3. Can the kurtosis be negative?
Maybe.
Then it can be negative.
When the value is less than series ex minus.
When the outcome of this expression is less than 3, then it could become negative, right? Has anybody started attempting the assignments? Please start it, okay? Revise the videos and start attempting the assignment. Unless and until you're able to complete the assignment, you will not be given a chance to work on the projects that we are handling.
Actually, I have started with the basic statistics.
Yeah.
The only problem I'm seeing here is like they have taken the snapshots from the Excel and kept it as images to calculate mean and median. Now
Your
we have
voice
to,
is breaking.
am I audible now?
Yeah, now it's better.
So I'm saying in assignments, right? I started with the basic statistics, and there what they have done is they have taken the snapshots from the Excel and put it in the as an image. Now the problem I'm facing is I have to jot down all the values in Excel and then only
No,
I can.
not really required. I think those snapshots are let you know that what exactly the data set. How
So
exactly
for
it
that
looks like.
data set only, right? I mean, it is asking that this is below the data set and calculate the mean median. Now it's
No, no, no.
like.
These data sets are already uploaded separately. I think it under your assignments itself, you can find the data sets as well. If you can't find it, please ping the salesperson who you are in touch with. They'll be able to get that data sets uploaded for you
Okay.
for your elements. You don't need to because it's too time consuming, right? You cannot just look at the screenshots and just keep typing in the values. It's waste of time. Okay. So unless and until you're able to complete the assignments, you will not be given a chance to work on the projects. Okay. These projects experience will give you a real-time like experience so that you will be able to handle the problems the moment you are able to transform your career. Right? The complete end-to-end life cycle of a project. Right from data understanding till deploying the models. Right? So please spend some time in revising the concept of what we are discussing and take the relevant assignments and complete that. And if you're stuck with anything during the assignment, there's a specific team whom you can reach out to get some assistance. Obviously, they'll not be able to help with the answers, but they'll help you with the approach. Right? Take this little seriously. Let me do this as well. We already completed R and Python basics. Is it visible? Next. What is the result of this? False. Because this
Yeah,
is nothing
false.
but a number, but this is a character because that is surrounded in double quotes, right?
Error.
Given within the braces course equal to data science, what will course.title return in Python? That will be auto-cased, right? Which one of the following will return the string representing the current working directory in Python?
D,
Which one? D?
B for Bangalore.
D. This gives the directory name. But working directory? C is the answer. Get current working directory. But if you'd like to change the working directory, CHDIR. Okay. Its OS is a library that is required to be able to interact with your hardware. So which of the following function of dictionary? What is dictionary, friends? Key value combinations. Key value combinations are nothing but a dictionary. Which of the function gets all the keys from the dictionary? Please attend the basics of R programming and basics of Python programming. You will get a notification. Okay, please enroll yourself, and whenever the sessions start, I think the schedule is already fixed. You can enroll for those sessions and go through it. Okay. Which library used for working with data frame in Python?
Pandas.
Pandas, right? So which one is used for visualization in Python?
Matplotlib.
Matplotlib, basic visualization, right? Okay, fine. The last session, we discussed about standard normal distribution. Why do we need to standardize the data?
To make it scale free.
Why do we need to standardize the data?
For making it scale free.
For making the data scale free and unitless. What do we mean by scale free? When you have a combination of variables, which are having different range of values. So it will be difficult for an algorithm to be able to extract the right insights from the data. And any calculations that you perform on such data would get influenced by the maximum values, would get influenced by the highest values. Thereby, we need to standardize the data. What is the formula to standardize the data? X minus mu by sigma. The standardization of the values is represented by Z. This score can be calculated by using X minus mu by sigma. So what is the range of values it takes once you standardize the data? What is the range of values you would get to see?
-3 to +3 standard deviation.
Exactly. It's not standard deviation. It will be between -3 to +3.
Okay, thank you.
As an alternative to this, we also discussed about normalization. What is the formula to normalize the data? Yeah. X minus minimum of X divided by range. Clear? What is the range of values you would get to see if you normalize the data? -infinity to +infinity is what you get to see when you standardize the data. But 99.999 or 97.8% of the data lies between -3 standard deviation to +3 standard deviation. That's where we are taking -3 to +3. But if you normalize the data, what is the range of values you would get to see? 0 to 1. When you have a combination of continuous data and discrete data, so you can apply normalization on the continuous data to convert that continuous data into the range of 0 to 1 so that it will be in line along with the discrete data. Clear? Okay, fine. So the next topic that we're going to discuss today is QQ plot. Quantile plot. QQ is different from quartile. Okay. What do you call this region? Interquartile range, right? It is obviously required to prove whether the data that you are handling is following normal distribution or not. The reason being, a lot of techniques and methods that the statisticians and researchers have developed that we can make use of readily if the data is following normal distribution. Right? In order to prove whether the data is following normal distribution or whether your data is normal, This QQ plot will be handy for us. Quantile plot. By looking at this data, the way the data has been spread, considering interquartile range, which is nothing but from Q1 to Q3. If the majority of the data falls on this reference line, this line is called reference line. If the data falls on this reference line, then you can consider the data is following normal distribution. Okay, let's see it practically. Clear the history from your console. Control L in R. At the same time, free up the RAM. Would have loaded a lot of data into the RAM, right? So free up the RAM, the GC and parenthesis, garbage cleanup. Okay. Once you load the data either into R or Python, the data is going to sit in the RAM. If you like to perform any further computations, they're going to occupy the remaining RAM. They're going to leverage the remaining RAM. Hence, the computations will be little slower if you load huge data sets. Hence, it's always a good practice. Once you are done with working with any data, it's better to free up the memory, right? So I'm loading a simple data set, MBA data set, which we already looked at. Control Enter to execute the command. Now the data is loaded. See if the data is following normality or not. The function in R is QQ plot. We have work experience and GMAT score.
Where do we attach MBA?
The moment you attach MBA, that means you're going to attach this data set to the session that you are working on. As long as the session, you're working on the same session, you don't need to repeat MBA every time. You can straight away refer the column names within the data.
Okay, thanks.
Okay. So let's see if work experience is following normal distribution or not, right? Normality or not. Just give me a second, please. For drawing the quantile plot, the function is QQ norm. Sorry, it's not QQ plot, it's QQ norm. Okay. But if you just draw this QQ plot, you will not be able to understand whether the data is following normality or not, unless and until we have a reference line. To get the reference line, it execute QQ line. So these two commands needs to be executed one after the other in the same sequence. Now you get the reference line based on which you can compare. You think the data is following normality or not by looking at this graph? Very difficult to judge, right? Some of us might feel, yes, the data is following normality. Some of us might feel, no, there are still a lot of data points that are falling apart from the line, not exactly on the line, right? Whatever the judgment that you're going to make just by looking at the plots is purely subjective. You need to rely upon a statistic measure to be able to exactly say if data is following normality or not, right? So for now, just remember, how do we read this plot? How do we build this plot? But when we get into subsequent sessions, I'm going to introduce you, how do we statistically measure whether the data is following normality or not? For that, basically, we are going to use the probability. There's a measure called probability that we're going to use when we build the model. Okay. Next thing that we're going to discuss is sampling variation. As the name suggests, if I have a population data, how many samples we can draw? I have a population data. How many types of samples we can draw? N number, right? Depends on the criteria you apply. Depends on the size of the sample you can accommodate. Depends on the technique based on which you are extracting the sample, like simple random sampling, stratified sampling, cluster-based sampling, various sampling techniques. But however, we need to understand the basics about, though you are extracting sample, irrespective of the accurate technique that you're going to use, they are going to follow certain properties. Sample mean varies from one sample to another sample. The same population data, if we extract different samples, sample 1, sample 2, sample 3, and so on. Sample mean X bar is going to be different from one sample to other sample. The X1 bar cannot be same as X2 bar. There will obviously be a difference between the sample mean, right? At the same time, let's consider this is normally distributed data. In normally distributed data, where the mean lies? In the middle, exactly in the center. How do you represent the population mean? How do
Mu.
you denote mu, right? Irrespective of accurate technique, whatever you use to extract the sample. Let's say this is the sample you extracted. And sample mean is represented by X bar. Your sample mean tends to be different from the population mean. It cannot be sample what you are extracting, cannot be an exact representation of your entire population. Right? And that's where, based on number of samples that you extract, S1, S2, S3, and so on, Sn, your sample mean is also going to be same, will be different from one sample to other sample. X1 bar, X2 bar, X3 bar, on Xn bar. Right? Since the sample mean is purely dependent on the type of the sample that you are extracting or the size that you can accommodate. Hence, even the sample mean can take random values. This is also a random variable, right? It takes different values. It cannot be same irrespective of the type of the sample that you extract. Right? For example, if we take a population of 4 data points, population size of 4, how many samples you can draw? How many samples of size 2 can be drawn from this population? How did you get that? Any formula? NCR. NCR is nothing but, how do you expand this NCR? N factorial
Five
divided by
minus R.
R factorial into N minus R factorial. So I have a population of size 4. In order to extract the samples which are of size 2, number of combinations is going to be 4C, right? Just expand this. 4 factorial means 4 into 3 into 2 into 1 divided by 2 factorial. 4 minus 2 is nothing but 2 factorial. 2 gets cancelled. 2 2s are. So the result is 6. Right? These are 6 different ways of 6 different samples that you can extract, which are of size 2. If you observe the sample size, each of these samples, if the sample mean is same for all the samples, it is obviously different, right? It is different, but at the same time, it can accept sample mean can take multiple values like a random variable. And the probability associated for each of these values become a sample mean would be equal. There is an equal chance that each of these values can become a sample mean. Hence, the probability is represented as 1 by 6. What is the probability formula, friends? Probability.
E into.
No, you are going too depth into the mathematics. We don't need that level.
Oh, okay.
Okay. Number of interested events divided by total number of events. Total, we have 6 sample means. Out of that, 1 to become a sample mean is an equal opportunity. There is an equal chance. As 1 by 6 is the probability associated with each of these sample mean to become each of these values to become a sample mean. Am I clear? Online folk? Any questions?
Ye- No.
Next thing that we're going to discuss is that a very, very important theorem that's called central limit theorem. It's also referred as CLT. I'm going to ask questions about this particular theorem till the end of our program. That's why it's very important. You're going to keep referring this. Okay? What does central limit theorem talk about? Central limit theorem says your sample mean distribution can be normally distributed if the population is following normal distribution. Your sample could follow normal distribution if the population is also normally distributed. Your sample could follow normal distribution even the population is not following normal distribution, provided you extracted a large size of sample. This is purely between population versus sample, friends. Your sample could follow normal distribution if the population data is following normal distribution. That is pretty clear. Your sample could follow normal distribution even if your population is not following normal distribution. For example, let's say this is your population distribution. Is it normal distributed? Is this normally distributed? No, right? Positively skewed. So median lies somewhere here and mean somewhere here, right? The sample that you are going to extract could even follow normal distribution, even your population is not normally distributed, provided you are taking a sample of size large enough. Then what should be the size of the sample to make it normally distributed? But why are we so much behind normal distribution? Why are we so much behind to prove whether our data is following normal distribution or not? Because of the fact that there are a lot of techniques and methods that are readily available for us to make use of, right? Your sample would still follow a normal distribution if the population is not following normal distribution, provided your sample size is large enough. Is that large enough is not subjective? That's of course it is subjective, right? But how big the sample should be to consider that as normally distributed? That we are going to see in the next slide. The sample could still follow a normal distribution, even the population is not following normal distribution, provided the sample size is large enough, right? And the mean sample mean is same as the population mean. Mean of the samples. It's called as first moment business decision of sample means. That means you are extracting different samples. These are samples. Sample 1, 2, 3, 4, and so on. And these are the sample means. X1 bar, X2 bar, X3 bar, and so on. What should be the mean of sample means? Mean of all your sample means will be your population mean. Okay. That's called first moment business decision of sample means. And the standard deviation of your sample mean. What is standard deviation? What exactly we talk about in case of standard deviation? What is the formula for standard deviation? What is the formula for standard deviation?
Square root of x minus
Standard deviation sigma is equal to square root of summation of x minus mu whole square divided by n.
Yeah.
So what are we understanding in the standard deviation? You're trying to understand how far each of the data point from its mean. Mean is the baseline measure for us to understand how far, understand the spread of the data. Correct? So now, standard deviation of sample means is going to be standard error. Sigma by root n is the formula for calculating the standard error, and standard deviation of sample means is treated as standard error. Here, and this is called as second moment of sample means. First moment of sample mean is nothing but the population mean, and second moment of sample mean is going to be the standard error. When the standard deviation talks about spread of the data or variability of the data within a sample, whereas standard error talks about variability of the data across the sample. Here, in case of standard error or population mean, we are talking about multiple sample means, multiple samples. This X bar of the standard deviation S are very much specific to a single sample, right? When the standard deviation S or sigma, S is for sample, sigma for sample. The standard deviation talks about the variability of the data within a single sample. Standard error talk about variability of the data between the samples. Am I clear? Online folks, any questions?
no.
Okay. Now, what should be the sample could still follow a normal distribution if the population is not following normal distribution, provided the sample size is large enough. How large is it? Statisticians have already proved that a sample size of 30 is considered to be large enough. But the sample size of 30 is really good enough for us to solve problems. In real time, we get to see the samples, millions, right? So this purely from a bookish perspective. But what you can do is, whatever the sample that you extract, make sure whether the sample size is adequate enough or not. You can cross-check by using these two formulas. A3 is nothing but skewness. If your sample size is greater than 10 into square of skewness, that means your sample size is good enough. Or you can check with kurtosis as well by using these two formulas. Where the skewness and kurtosis are sample statistics. They are not population parameters. Am I clear? If I ask you, what would be the temperature at 8 o'clock in the evening, in the night? What could be your answer? Twenty to 24. Okay, that's good. Why are you giving an answer in terms of range? Why not exactly a number?
Because this is a continuous data.
It's a continuous data, and there's a high chance that your prediction could go wrong, right? Continuous data in the sense, it could be 20 degrees, it could be 20.2 degrees, 20.8, whatever, the decimals, to the precise level that you are looking at. Hence, whenever we're dealing with the predictions of a continuous data, it is always good to come out with a range, rather coming out with a single value prediction. Because there is a probability associated with the single value predictions in case of continuous data is always 0. Clear? And that's why while predicting the continuous data, we always need to go with a range of values. It will be a lower bound value and upper bound value. But if I say temperature is going to be minus 50 degrees centigrade to 100 degrees centigrade, would you be interested to take this prediction? No, right? Why do you think? Because the range that you are coming out with is nowhere near to the realistic one that is going to be. The prediction should always be close by the realistic numbers. If any other forecasting agency comes out with this kind of prediction, do you think people are going to look at that? There will not be any takers for that kind of prediction, right? And the range that you're coming out with for predicting a continuous data. It's called confidence interval. Reason why we are saying it as a confidence interval is always a level of confidence associated with the prediction that you are coming out with. Say temperature is going to be between 20 and 24 at 8 p.m. today. The immediate question I would ask is, how confident are you? How would you express your confidence? In terms of percentages? I'm 90% confident. I'm 100% confident. Right? I'm 80% confident. Clear? The percentage that you are expressing, that you are using to express your confidence, is represented by alpha. That means your prediction is going to be, let's say you are predicting with 90% confidence. Your alpha is going to be 90%. Means 90% of the times, actual value is going to fall in this range of your prediction. Right? Am I clear? When 90% of the times, your prediction is going to be correct, what is the chance that your prediction could go wrong? 10%, remaining 10%, because the remaining 10% would it be on one side of this region or would it be on both the sides of the region? Both the sides. So we split this remaining 10% into two equal parts. So 5% of the time, actual value fall above your prediction, maximum value of your prediction, or below the maximum value of your prediction. Yep. So the chance of going wrong is a chance of going right, middle region. That's nothing but your confidence level, which is alpha. And the remaining 10% is going to be 1 minus alpha. When alpha is 90%, one minus alpha is going to be 10%. Okay? When alpha is referred as confidence level, one minus alpha is referred as significance level. Significance level is represented by 1 minus alpha. Confidence level is represented by alpha. The confidence level talks about the chance of going right with your prediction. 1 minus alpha, or the significance level, talks about chance of going wrong with your prediction. The terminology difference, nothing more than that. Am I clear? Online folks?
Yes, I'm.
Will you please go through this case study? Then we'll discuss about this. Just spend a couple of minutes and go through this case study. Anyone is freshers? No experience, no work experience. So I would recommend you guys to create a GitHub page. You know GitHub, right? The code repositories. Create a page. Whatever the assignments that you're going to do, please upload all your code and everything into GitHub. And also create a Kaggle page for you. Kaggle will let you know how to create. But GitHub you can create, because whatever the work you are going to do, maybe if you're going to spend next 6 months of time in learning this program, let us say, the assignments, whatever you're going to do, and after which, what are the projects you are going to do, all the work can be uploaded to your GitHub page. so that it works as a proof, showcase what you have done even for the recruiters. If anybody asks you, what is the proof that you have done all this, you have learned all this, you can open your GitHub page and showcase. So these are the dates I solved this problem. It works. And you can paste the GitHub link in your LinkedIn profile as well. Okay.
The assignments that has been given here, those assignments you are saying we can upload there in GitHub.
Yeah, you can upload on your GitHub page. GitHub, you can have your own personal account, right?
Okay.
So you can upload, and if you wish to expose that to the public viewing, you can expose, and you can use that link in your LinkedIn profile. And that works for freshers, not for the work experienced people. Okay. Which format you are talking about, Harika? Sorry, Hanika? Which format you are talking about? Uploading in GitHub. Yeah, you can just fine tune the presentations or the code that you're going to prepare. Then you can upload that work. Okay. And get them reviewed by our assignments team before uploading, so that you will, if at all there are any suggestions, you'll be able to improve on that. Okay. Are you done, guys? Going through this case study. What is given here? University with 1 lakh alumni is thinking of offering a new affinity credit card to its alumni. Profitability of the card depends on the average balance maintained by the cardholders. Right? What do you think? How the banks got so much of money to be able to lend the interest? Savings account, fixed deposit, savings account, whatever we have, we deposit. Banks actually take the money and lend it out, right? Similarly, the profitability of the cards that this university would like to launch, it is depending on the average balance that these cardholders would maintain. A market research campaign is launched in which about 140 alumni accept the card in a pilot launch. The average balance maintained by these is $1,990, and the standard deviation is $2,833. Assume that the population standard deviation is $2,500 from previous launches. What we can say about the average balance that will be held after a full-fledged market launch? What is this 1 lakh here? Population size, that's capital N. Clear? Out of this 1 lakh alumni, what is the sample that they have taken? 140. 140 alumni accepted this card in a pilot launch. I mean, that is a sample, small n, sample size, right? And what is this 1990?
Mean of sample.
Which mean? Sample mean, right? That is a X bar. Here. Clear so far? What is this 2833?
Standard deviation of the sample mean.
Standard deviation of the sample mean. Do we have standard deviation of sample mean? I'm not talking about the central limit theorem. How do we represent? What exactly is standard deviation? Is it population standard deviation or sample standard deviation? It's a sample standard deviation, right? How do you represent the standard deviation of a sample? Yes, right. Clear? Now, what is this 2500? Population standard deviation. That is sigma. Right? Now, what do we need to find out? Average balance of population. Nothing but mu we need to identify. Everybody clear about the case study, the problem, and how do we denote each of the values that are given in the problem? Right? So, can I predict the average balance of the entire population by representing a single value? You know the sample mean. Can I predict the population mean as a single value? What is the probability associated with a single value prediction with continuous data? 0, right? Hence, we need to predict that as a range of values. We cannot go with a single value prediction, right? Because of this, see, right now we have taken 140 samples. 140 people are randomly picked out of overall 1 lakh people. What if we choose a different 140 people? The sample mean could be different, right? Because the sample mean is different from one sample to other sample. Central limit theorem, right? And that's where, while estimating this continuous data, we go for an interval estimate. Calculate the interval estimate. We obviously make use of the underlying measure as the point estimate. Point estimate is nothing but sample mean. Because we are predicting the population mean here. We would take the sample mean as a baseline for us. That's nothing but the point estimate. Plus or minus the margin of error. What is the error you can make? You can go either side of the mean, either side of the sample mean, right? The confidence interval Ci is calculated using formula x bar plus or minus Z1 minus alpha into sigma by root n. X bar being the point estimate, is nothing but the sample mean. And this margin of error is nothing but, where did we look at this sigma by root n, friends? What do you call that? Standard error. Is nothing but the standard error. Into Z of 1 minus alpha. What is Z? Z is nothing but standardized values. Z scores. Z score at 1 minus alpha. What is this 1 minus alpha? Level of, is it confidence level or significance level? Alpha is confidence level. 1 minus alpha is significance level. Chance of going wrong. Means we are talking about the error here. When do you commit the error? When your predictions are different from your actual, that is the error that you are making, right? That's why we are taking the significance level into consideration. But since we are coming out with a prediction, we need to predict that with certain level of confidence. This confidence is represented in terms of percentages. 90% confidence, 95% confidence, 99% confidence, right? Out of all this formula, what is that we don't know? Calculate this confidence interval. Do we know what is sample mean? That is given in our problem. Do we know what is sigma? Sigma. Population standard deviation. Is that given in our problem? Do we know what is small n? What is that? Sample size. That's 140. Right? Out of all this, we don't know only this part. How do we calculate G value at a given significance level? Right? Know that we will be able to come out with an interval estimate. Sorry guys, 1 minus alpha is the confidence level, alpha is the significance level. Alpha is the significance level, 1 minus alpha is the confidence level. So that means calculate D value at a confidence level, 1 minus alpha. If I'm talking about 90% confidence, I mean the chance of going right is 90%. This is 1 minus alpha. And what is the chance of going wrong with your prediction? 10%. That is equally distributed on both sides. 5%, 5%. Clear? Oh, this alpha, the significance level. What What is alpha here? 1 minus alpha is 90%. What is alpha? 10%. When 1 minus alpha is 90%, alpha is 10%. How do we calculate a G value at a given confidence level? The table. Okay, just pay attention here, friends. We're calculating G value at 90% confidence level. Whenever we are looking at G table, we always need to look from left to right direction. We already seen, right? When we were calculating the standardization values, left to right. So in order to reach this point, what is the area under the curve that I need to cover? What is the area under the curve that needs to be covered? If I represent the same thing in the format of decimals, %90 is nothing but 0.9, right? 5%, how do you represent in decimals? 0.05. And this is 0.05. So from left to right direction, in order to reach to this particular point, what is the area under the curve we are covering? 0.95. So where do we have this 0.95 in this table? Between these two values? Clear? What is the G value for this? How do you look at the G values? 1.6 decimal 0.04. That means it is 1.64. Right? And what is the G value for this? 1.6. Since we are looking at the middle value for these two, we need to take the average of these two. What is the average of these two? 1.645. Clear? So G value at 90% is 1.645. Is this logic is clear, friends? Now, can you tell me what is the area under the curve that I need to cover to calculate G value at 95% confidence level? Online folks, what is the area under the curve that we need to cover to calculate G value at 95% confidence level? Aditya, Harika, Nitesh, Prasanna.
Is it 1.96?
No, I'm not asking about G value. I'm asking about the area under the curve.
7.5?
7.5.
97.
97.5. That is 0.975, right? So to calculate Z value at 95% confidence level, that means the middlemost will have 95%, which is 0.95. And the remaining 5% will be equally distributed on both the sides. 2.5%, 2.5%. 2.5, how do you represent in decimals? 0.025, 0.02. So the area under the curve that you need to cover is 0.95 plus 0.025. That is 0.975. Yeah. So where do we have this 0.975 in this table? .97. So G value for this is 1.9 plus 0.06. That is 1.96. This is the G value at 95%. These values are very important, friends. At least G value at 90%, G value at 95%, G value at 99%. You need to remember these values. G value at 90% is 1.645. G value at 95% is 1.96. Now, what is the area under the curve we need to cover for G value at 99%? Right? 995. Where is it? Nine nine five.
0.5?
is between these two, right? 2.575. Clear? Online folks, are we clear? How do we calculate the G value?
Yeah.
Okay. Now, can you solve this problem and tell me the answer at 95% confidence level? Sorry. Somebody has got a question? What would be the average balance that if you would launch this program for the entire alumni? Let's take a break and come back and see how do we solve that problem. Yeah. Let's come back by 4:20, online folks.
Okay.
Okay, at 90% confidence. So these are the values. 1642.428 is the lower bound value, and 2337.572 is the upper bound value. Clear? Now, do we need to refer the G table for calculating this G values at a certain confidence level? Not required. Q norm is the function in our Q norm of 90%. What is the area under the curve that we need to cover? 0.95. So Q norm of 0.95 gives the G value at 90% confidence level. It is 1.645. So similarly, Q norm of 95%, what is the area under the curve we need to cover? 0.95%. 975. 1.96. For 99% confidence level, 0.995. 2.575. Clear? Python. Let me just load this data. Why do we use pandas? Why do we use pandas library? For data manipulations, for loading the data, slicing and dicing the data, doing the aggregation. Yeah, most of the pre-processing work that you would be doing using pandas library. Just importing the pandas library, then loading the MBA data set. SciPy for scientific Python, scientific calculations. in Python, function that we're going to use for calculating the z value is norm dot ppf, percent point function. Why are we treating that as a point function? Reason being, we would like to cover the area under the curve till this particular point. That's why it is called as percent point function. Clear? That should be. You can remind me towards the end of the session. Point 975 is the area under the curve that we would like to cover a 95% confidence level. But why are we passing this 0, 1? What is 0? What is 1 here? What is this G formula? G is equal to x minus mu by sigma. And this is nothing but the area under the curve we would like to cover. If the data is normally distributed, what will be the mean of a standard normal distribution? Standard normal distribution. 0, right? So mean mu will be 0, and the standard deviation sigma will be 1. And that's the reason we are passing these are the arguments. Clear? And this is for 90%. 0.95 is the area under the curve, 1.645. 99%, 2.575. And to calculate the G values, function is cumulative distributive function, CDF. This is X, this is a mu value, this is sigma value. Remember, solve this problem. This is all. Probability to cover the area under the curve. To calculate the area under the curve, CDF is the function, cumulative distributive function. To calculate the G value, PPF, percent point function. To draw the skewness in Python, data set dot calculate the skewness. For each variable, the skewness will be calculated and will be given to you. Kurtosis dot curt. In order to calculate the kurtosis or skewness for a specific variable, you need to refer a column. This is the syntax. Data frame name within the square bracket, the column name in the quotes, dot kurt or skew. Same as this one. Clear? Histogram. You have to import the library called matplotlib. Within matplotlib, there is a sublibrary called pyplot. You need that for drawing the histogram. PLT is the short name we have assigned for matplotlib.pyplot. PLT dot hist is the short function for histogram. Hist of the data frame and the variable for which you would like to draw it. Clear? Box plot, same PLT matplotlib.pyplot, which is referred as plot PLT dot box plot of respective variable. And if you'd like to add the label, this PLT dot y label is the function. Label means the caption. Yeah. Clear? Bar plot, PLT dot bar. Argument X dot shape. Okay, somebody has got the internet issue, the network issue. Dropping off and joining back. Oh, no problem. Oh, okay. X argument is missing in that. Plot. Okay, fine. Now, we calculated the confidence interval, the interval estimate, based on a certain confidence level. Now, and this is the answer we got, right? For 95% confidence level. Average balance, the entire alumni would maintain, would be between 1976 and 2404. What does that mean? Mean balance of the population lies in the range of this. Is that correct? Is that a correct statement? The mean balance is in the range 95% of the time, because we calculated at 95% confidence level. Is that correct? 95% of the alumni have balance in this range. Is that correct? Right? All these three are not correct. These three are incorrect. Correct interpretation is mean of the population has 95% chance that it will be in the range of this if you pick a sample randomly. Because we have actually made use of sample data, extrapolate versus the population. Sample statistic, inferential statistic. Right? The mean, sample mean that we used is a sample, is the result of a sample of 140 alumni. Right? What if another 140 people are being taken? And that is where standard error compensates with respect to difference in the sample you could pull out from the population. And the mean of the population will be in this range of 1576 and 2404 for 95% of the random samples. It's not for 95% of alumni. It is for 95% of random samples. Clear? Fine. You know, problem that we solved, we were given the population standard deviation. And this is the sigma given, population standard deviation. What if you are not given the population standard deviation? If you know the population standard deviation, we are resorting to redistribution to calculate the interval estimate. Right? What if the population standard deviation is not given to us? And that's where we resort to redistribution. Calculate the G value. The formula is x minus mu by sigma. Calculate the T value. Look at this formula. Are these sample statistics or population parameters? All are sample statistics, right? X bar minus mu is the population mean divided by S by square root of n. S is nothing but sample. What is S? Sample standard deviation divided by square root of n. When we are looking at the t distribution, the random variable t is taken, which is following, or which is actually whose population is normally distributed. So you pull out a sample out of that normal distributed population. T is a random variable as per the t distribution, n minus 1 degrees of freedom. What is this degrees of freedom? N minus 1. Where did we look at this degrees of freedom? Degrees of freedom is equal to, formula is n minus 1. N is nothing but the sample size, n minus 1. What is the sample variance formula? What is sample variance formula? How do we represent sample variance? S square, right? Sample variance. What is the formula? Summation of x minus x bar whole square divided by n minus 1. Did we discuss about degrees of freedom when we discussed about variance, sample statistics? Till n minus 1 position, you will always have the freedom of selecting of your own values, though you are supposed to meet a criteria that is being set. You need to purchase 4 items. But the total cost of the 4 items should not exceed let's say 40 rupees. So do we need to buy each and every item exactly for 10 rupees each? Not required, right? You will always have the freedom of purchasing an item of your own price. Now, what should be the cost of the 4th item that you need to purchase? 10, right? Do we have any other option when you come to the last position? That is the nth position. No, right? So you'll always have the freedom till n minus 1th position. That is called degrees of freedom. Clear? If you're solving, or if you're calculating the interval estimate using a t-distribution, it tends to be more robust compared to d-distribution. Because t-distribution considers sample statistics into consideration in its formula, right? But how it works, how robust it can be against the d-distribution. Just pay attention, your friend. How did we represent d-distribution? D that follows normal distribution between its mean 0 and 1. T-distribution is also not any different from that. Even t-distribution tends to follow normal distribution between its mean 0 and standard deviation 1. But the difference between d-distribution and t-distribution will lie when we are dealing with when the degrees of freedom equal to 1. What would be the sample size? Hmm? 0. When degrees of freedom equal to 1, what is the sample size? 2, right? Degrees of freedom, the formula is nothing but n minus 1. So sample size n will be 2. When you are dealing with small sample size, the t-distribution looks like this. This is a t-distribution, this is a g-distribution. When degrees of freedom equal to 3, what would be the sample size? Come on, guys. All right. No doubt, right, in that. When the sample size is increasing, your t-distribution tends to move towards the g-distribution. The gap keeps reducing between g-distribution and t-distribution. If you increase the sample size further, degrees of freedom is 10 means sample size is 11. See now, the gap is very much narrowed down. And degrees of freedom equal to 30 means your sample size is 31. Both d-distribution and t-distribution look to be the same. Right? You remember what would be the adequate large or adequate size of a sample? When can you say it is large enough? When sample size is 30, that's what is proved to be the large sizes, right? When your sample size is moving towards 30, your t-distribution approaches towards the d-distribution. Hence, when you are dealing with small samples or samples with varied variances, t-distribution tends to outperform your d-distribution. Clear? Any questions? Online folks? Interval estimate formula to calculate if the population standard deviation is given. Interval estimate is x bar plus or minus g1 minus alpha into sigma by root n. We already seen this. If the population standard deviation is not given, calculate the interval estimate. Formula is x bar plus or minus E1 minus alpha. 1 minus alpha is the confidence level, is 90%, 95%, and so on. And n minus 1 is the degrees of freedom. Instead of sigma, you will take s by root n. This is nothing but sample standard deviation. Clear? Now,
Small
we
question on
calculate.
that. Sorry, small question on that. So when I say n minus 1, t 1 minus alpha and then n minus 1, how are we going to look at the value?
Okay, fine. Let's open the t table. T table, these are the degrees of freedom. No problem, Subramanian. These are the degrees of freedom. If you observe here, degrees of freedom values are given in a series from 1 to 30. Right? And later on, we have 40, 60, 80, 100, 1000. On the columns, you have one tail and two tail. One tail is nothing but if the data is distributed like this. So how many tails you have in this? Two tails, right? You're working with 95% confidence. So what is the chance of going wrong at each tail? 2.5%. The 0.25 is what we are representing in terms of one tail. Same can be represented 0.50 from the two tail perspective. Okay. Now we will see how do we find the values here. Now, calculate 95% confidence level, interval estimate at 95% confidence level, by thinking we are not given the population standard deviation. When the population standard deviation is not given, we have to go with sample. Population standard deviation is 2500, whereas sample standard deviation is 2833. S by root n. This is nothing but S by root n. Here. Calculate t value at 95% confidence. Same area under the curve that we would need to cover is 97.5, 0.975, right? But degrees of freedom, nothing but n minus 1. What is n here? 140. N minus 1 is nothing but 139. So we need to look t value at 0.975 and 139. Where do we have 0.95? .975 means what is the value you need to look at in the columns.
Seventh column, T underscore. On top, it's saying T.97. Is that the one?
Is on 0.975, right? You're working with 95% confidence level. The chance of going wrong is how much? So this 95% is nothing but 1 minus alpha. Chance of going wrong is nothing but alpha. Significance level is 5%. This 5% is equally distributed on both the tails. 2.5% and 2.5%. Clear? So now, on two tail, you need to look for 5%. 5% is nothing but 0.05. Right? On one tail, you will have 0.025. Are we clear? Coming to the degrees of freedom. What is n minus 1 that we got in our problem? 139. So do we have 139 listed on the rows? Degrees of freedom? No, right? So we have 100 and the next one is 1000. We need to look at the closer value for 139. Which one is closer? 100 or 1000? 100. We are looking at 95% confidence level. %95 confidence level with 100. How much? $1.984. So that is a p-value at 95% confidence level. So p-value at 95% confidence with 139 degrees of freedom is how much? 1.984. What was the G value at 95% confidence level? 1.96. They will be very close by. Values of your T distribution and D distribution will be very close by. But major difference you can identify till the sample size of 30. Lower the sample size, you will see major gap between your T values and D values.
So in case my degree of freedom is 800 or 900, we will like take the value of 1000, right? That's
exactly. Then you need to take this 1.962.
But if it is 500 or 600, then where should we look at?
If it is 600, then which value it is closer to? Is it 1000? 1000 you need to take. If it is 500, take the average of these two. If you have exactly 500, take the average of these two values. Clear?
Yeah.
We are done with basic statistics. As part of the last bit of basic statistics, we're going to discuss hypothesis testing. Once we are done with basics of statistics, we'll start with machine learning. Okay, linear regression, logistic regression. Then we will be shifting between unsupervised learning and machine learning. We'll be learning unsupervised learning like clustering, dimension reduction, association rules. And once we are done with all unsupervised learning, then we'll again come back to machine learning and discuss about classification techniques like naive Bayes, Bayesian trees, random forest, nearest neighbors, neural networks, support vector machines, XGB, gradient boosting, bagging and boosting, and LGBM, light gradient boosting. Yeah. So finally, we will be discussing the time series forecast. What is hypothesis testing? Any idea what is hypothesis testing? Hypothesis is all about framing assumptions about the business problem that you're solving and proving those assumptions, whether the assumption is correct or not. It's all about hypothesis testing. Right? What kind of assumptions we make? Let us say you're opening a retail store. Business problem is whether to open a retail store or not. When do you open the retail store? As part of the analysis you conduct, you would define various parameters. The average income of the people who are going to locate in that area is about certain amount. Let's say if it is more than 15K or 20K or 30K, then you think you have a better chance that you can break even your investment in few years or in few months, right? And you take various parameters into consideration. Let's say the average income, the gender of the people who are staying in that area, age group. Yeah. Now, let us say if average income is less than or equal to 30K, would you prefer to open the store? If 30K is proven to be your break-even point, if average income of the people who are staying in that locality is less than or equal to 30K, would you prefer to open the store? No, right? Because there's no chance that you would get an investment back. You're pouring in a lot of money, a lot of investment. But if the average income is greater than 30K, would you prefer to open the store? These are nothing but the assumptions that you are making. These are in line with your objective, what you are trying to attain. Your objective is to open a store. This cutoff numbers, what you are coming out with, would be in line with your business objective. If your average income is less than or equal to 30K, and you feel you don't get enough support to get your investment back. But how do you know whether the average income is less than or equal to 30K or not? It's an assumption, right? It's just an assumption in line with your business objective that you are framing, but you don't have any actual proof to be able to do that assumption. Hypothesis testing helps you to prove the assumptions that you make about your business objective. Hypothesis testing is a kind of backbone for proving these assumptions. But yes, of course, we will be learning this as part of basic statistics. But as part of machine learning or unsupervised learning or any algorithm that you're going to learn, you would not get to see proving these assumptions explicitly using hypothesis because of the fact that inherently it is being taken care by these algorithms. I would be touch basing upon when we reach to that level. right? First, let us see, how do we prove these assumptions? How do we frame the business problem? About a case study, how do we frame the business problem? And how do we do these assumptions? Even before proving these assumptions, we need to frame the hypothesis statements. There are two types of hypothesis statements. One is null hypothesis, which is represented as H naught. The second one is alternative hypothesis. It is represented by H1 or HA. A for alternative. Yeah. Let us say these are the actuals. And these are your predictions. Actual H naught is true. Actual H1 is true. H naught is a null hypothesis. H1 is the alternative hypothesis. And as per the predictions, you are failing to reject H naught. Fail to reject H naught. What is fail to reject H naught? Sorry? That means you are accepting H naught, right? But these terminologies are little tricky. Statisticians, you know, right? They don't go easy with people. Okay, that's where this and terms will come into the terminologies. You are considering H naught or you are accepting H naught. And second option is to reject H naught. When you are rejecting H naught, what are you accepting? You are accepting H1. Clear? When both predictions and actuals are the same, is that a correct decision or incorrect decision? So here, you are failing to reject H naught. That means you are accepting H naught. And here, H1 is true. Both are same. Your prediction is in line with your actuals. That means you are accepting. That is a correct decision. The predictions are in line with your actuals. And this is called confidence is represented by 1 minus alpha. Yeah. And here is the alternative hypothesis, H1. Actually, H1 is true. And your prediction says reject H0. That means you are accepting H1. Is this a correct decision? The fourth quadrant. This is also a correct decision. Right? This is represented by 1 minus beta, or power of the test. Power of test. I'll come back to that. Why we are calling that as a power of the test. And let's talk about this. Now H0 is true, actually, and your prediction says reject H0. It means you are accepting H1 or alternative hypothesis. Is that a correct decision or incorrect decision? Incorrect decision, right? Actually, H0 is true. Your test says accept alternative hypothesis, H1. So you are going against the actuals. Predictions are going against your actuals. So that's where it's an incorrect decision. And this is called as alpha. What is alpha? Significance level. Means chance of going wrong. When 1 minus alpha is confidence, this alpha is represented as type 1 error. This is an error, right? Incorrect decision. That's why it is represented as type 1 error. And the left quadrant, which is there, your H1 is true. But what is your test saying? Fail to reject H0. That means accept H0. Whereas H1 is true actually, and your test says accept H0. Is that a correct decision or incorrect decision? Incorrect decision. And this is represented by beta. Is also called as type 2 error. Here, 2 by 2 quadrant. Very important to understand, because when we get into the classification problem solving, the naive Bayes, nearest neighbors, decision trees, random forest, whenever you are solving a classification problem, and this is the most reliable way of measuring the accuracy. Okay. What are we doing here? Nothing but we are trying to understand how far our predictions are in line with the actuals. It means we are comparing the predictions versus actuals. That's it. We are not doing anything more. H0 or the null hypothesis will always represent the status quo. Whereas H1 or the alternative hypothesis, H1 or HA, will always attract action. That means in H0, you will have no action statements, and H1 or HA, which is the alternative hypothesis, you will have action statements. What are the actions here? Opening a store, not opening a store. Which one is the action? Opening a store. When do you open the store? If actuals and predictions are the same. No, but when do you open the store? If the average income is more than 30K, that's when you are going to open the store, right? Let us say you have taken a sample of 100 people who are staying in that locality. And you made some assumptions about them and you did the predictions with regards to what would be their average income. You are failing to reject H0. What is your H0 here? What is the business problem? Open a store or not, right? The H0 is nothing but, which is the no action statement, not opening the store. When do you not open the store? When the average income is less than or equal to 30K, you're not going to open the store. Right? When do you open the store? When your average income of the people who are staying in that locality more than 30K. That's when you will open the store. And if you observe equality symbol, because there are only two conditions. Either the average income can be less than certain criteria, what we said, or greater than. But the equality symbol would always be attracted by null hypothesis statement. Okay. Null hypothesis always maintain the status quo, would always attract no action statements, and is equalities will be attracted by null hypothesis statement. And alternative hypothesis will always talk about the action statements. Clear? Now, here these are fail to reject H0 predictions. Reject H0. This H0 is true. H1 is true. Right? And out of 100 people you analyzed, upfront you did analysis, and later on you are comparing your predictions with the actuals of those 100 people. Clear? That's where we are performing our test between the predictions versus the actual. Out of 100 people, let us say, what is the total of all the 4 quadrants? 100. What is this 30? Their actual income is not greater than 30K. It's actually less than or equal to 30K. And your test also, your predictions also saying the average income less than or equal to 30K. Right? This is the correct decision. That's the correct decision. 1 minus alpha or confidence. And how about this 40? The average income is greater than 30K actually, and your predictions also say you're getting more than 30K on an average. Is that the correct decision? Yes. Represent that with 1 minus beta. But why are we calling that as power of the test? Reason being, if it is proven correctly, or if your predictions are correct, and based on this, you would have gone and opened the store, right? Because there is an action involved. So your predictions are helping towards taking an action, and that is why this is called power of the test. And how about this 14? The average income is actually less than or equal to 30K, but whereas your prediction says you're getting more than 30K. Means if you go based on your predictions, you would have gone ahead and opened the store, but you are failing by this much. Your predictions are incorrect by this much. Is that the correct decision or incorrect decision? Incorrect decision. This is a type 1 error, right? How about the 16? Actually, they are getting more than 30K, but your prediction says they're getting less than 30K, right? Is that a correct decision or incorrect decision? Incorrect decision. Represented by beta. Now, with relevance to this business problem, which error do you think is most dangerous? Alpha? Type 1 error? Why do you think so? Just tell me, why do you think it's alpha? No offense. Hello, info.
Is that because of HO is actually true, but we are rejecting that?
HO is true, but we are rejecting it. But how do you relate that to the business problem we are solving? Exactly. So what kind of error you are committing here? How many errors we have? Type 1 error and type 2 error. Alpha and beta. What is happening in case of alpha here? Your prediction says these people, 16 people, 14 people, are getting, their average income is more than 30K. But actually, they're not getting an average income of 30K. So if you believe your predictions, you would go ahead and establish a store. But what will happen? Actually, they are not getting more than 30K. That number of customers would not turn out to your store. Thereby, you will incur losses. You will not get your investment back. But what is happening in case of beta? They're actually getting more than 30K. Your predictions says not getting 30K. What will happen, Max, if you believe your prediction? You will not open a store. You would continue with your existing setup. You will not open a new store, right? If you would have opened a store, you would have been a little more profitable. But right now, there is no harm to your current situation, right? But in case of alpha, you would turn out into losses, right? That's where, in this particular context of the business problem, type 1 error is more dangerous. Am I clear? Any questions?
Is there any instances where type 2 error is more dangerous?
Yes, there are. That's where I'm heading towards. If you have any questions so far on what we discussed, you can ask. So is always type 1 error is dangerous? Not exactly. It purely depends on the business problem that you're solving. Okay. Now let me take another case study. These are your actuals. These are predictions. This is H1 is true. Oh, sorry, H0 is true. And H1 is true. Fail to reject H0. And reject H1. Let's say predicting where the patient who is going to turn out next to hospital is cancerous or not. Based on various measures you are capturing, you are building a model. Based on that model, you are going to say whether he is likely to attack the cancer or not, right? The business problem what we are solving here is patient is cancerous or not. Alternative, null hypothesis H0 is patient doesn't have the cancer. Alternative hypothesis H1 or HK is the patient has got the cancer. Right? Now, I built a model. Based on that model, I predicted whether the patient is going to be cancerous or not. Now, already built that model. I'm using that model to predict whether the next patient who is going to walk in is likely to be attacked by cancer or not. And I started using that model for next 100 patients. By the time I complete examining this 100 patients, I will also have the actual results available to me. Actually, whether the patient has got the cancer or not, right? Let's say the data is distributed like this. This is the correct decision. The patient doesn't have the cancer, and my prediction also says they don't have the cancer. 1 minus alpha, confidence. And this is also a correct decision. The patient has got the cancer, and my prediction also says he or she has got the cancer. This is the power of the test, 1 minus beta. And this is alpha, and this is beta. Now tell me, which error is more dangerous? Beta? Type 2 error? Why do you think so? You need to think from the business problem perspective. Why do you think type 2 error is more dangerous? Okay. Patient not treated. It's not quite clear, Hanika. What's happening in case of alpha? Where actually the patient does not have the cancer. But your prediction says he or she has got the cancer. Huh? Sorry? But they'll undergo depression, right? What will happen? Patient would undergo a depression. He is clever enough. He would undergo second opinion or third opinion, right? But what's happening in case of beta type 2 error? They're actually having cancer, but the very good model that you have built is predicting that they don't have cancer, right? The patient will keep enjoying as it is. And one fine day you will come to know about the power of your model. Okay? So which is more dangerous? It's causing the life. That's why it depends on the problem that you are solving. The type 1 error or type 2 error are dangerous. Are we clear now? Yeah, that's not as serious as type 2, right? That's what you meant to discuss, right? Yep. Yeah. I'll stop here for today. We'll continue various types of hypothesis tests and how do we frame the business problems with the case studies. We'll take few case studies and solve them by using different types of hypothesis tests. Okay. So any questions, friends, so far on what we discussed today? I think Chilpi, I think if I'm not right, you are the one who asked that question. You had some question from our last week's discussion. Yeah, you can unmute yourself and just ask your question.
So I just wanted to know if we can add custom columns in R or Python. Using R and Python to the existing data frames. So since, for example, if I don't know the database, what is there, and I just want to add some custom columns, my own defined columns, what function which we can use there for R in R or Python?
No, you can simply like create a column, new column with that a name and pass in the values that you want. But when do we need to add these custom columns is more important. There are a lot of instances where you would need to create derived variables out of the existing variables that you have, out of the base variables that you have in your data set, right? You would need to calculate certain formula based on your existing base variables and create a new variable and start making use of that variable for your further analysis, right? Simple, like in R or Python, as good as any variable. I think we've already seen that, right?
Like for Python, we did use that dummies thing, but in R, I
Not
think
just dummies. In R also, like, it's not very different.
Can I ask one question, please?
Yeah, let me just complete this, then I'll come back to you.
Yeah.
Okay. Look at here. What are we doing? We are creating two new columns and we are passing the values at the same time, right?
yeah.
In R also, the syntax is very simple. So we're creating a new list item here and passing different values to it. right? For calculating a new variable or for creating a new variable, syntax is very simple. Like the data frame name, within the square brackets, just mention the name of the variable that you would like to create. And just assign the values that you would like. Is that clear, Shilpi?
Yeah, I think that helps. Thank you.
Okay. And who has got the other question?
Yeah, this is Subramania here.
Yes, Subramanian, tell me.
When I check the dashboard, I'm not able to find the assignment section. How do I find that one?
You're not finding the assignment?
Yes.
You just ping in our WhatsApp group so that the relevant team will help you.
Okay. Thank you.
Okay. And there's a person facing kernel error after installing Jupyter Spider. How to fix this? What exactly is the kernel error? Prasanna?
Sir, sir, after I'm having Python 3.7 installed.
Mhm.
So when I tried to install this Anaconda, when I open Spider, when I launch Spider, it's showing kernel error. So I could not be able to do any programming.
So did you install correct version of Anaconda? Is it Windows Anaconda
Yeah,
version?
Windows only.
Okay. Just
I have installed Python 3.7 and Anaconda also I have installed. When I tried to launch a Spider 3.3, I have followed whatever the instructions you have said, but it's showing kernel error when I try to execute the programs.
Yeah, actually for me also in Spider, it's not working. I mean, it is not, I'm able to code and all, but it is not showing me the results in Spider, but in Jupyter, though it shows me the results.
no. In Spider, what you need to do is like, is a Spider. Just go to View, Windows Layout, then select RStudio Layout, so that you will have this console in the bottom where the results will be shown.
Oh, okay, got it.
Okay. But for your problem, I think it's Subramanya, right? Or Prasanna. So the
Yes,
kernel,
sir. Kernel error, even in Jupyter also, I am getting on the corner of the screen, I'm seeing kernel error.
I think it's not installed properly. You would need to uninstall Anaconda and reinstall it. So once you launch Jupyter, the instructions which are given is basically how many versions of Python do you have in your machine?
I'm having Python 3.7 and 3.4, sir.
And why are you opening the kernel with 3.3? Sorry, Jupyter with 3.3.
No, I just opened with new program, new. It shows Python 3, and
Okay.
that's all.
It's only Python 3 that you have like.
Yeah, it's showing Python 3. Yeah.
Okay. The moment you click on that,
If I click on that on the corner of the page, it's showing kernel starting is showing, no, for you. For me, it shows kernel error, it comes.
so it's not installed. So uninstall Anaconda and download it and make sure you have a good internet speed and then reinstall it again.
I also tried that, sir, but again, I'm seeing this problem.
Just copy and paste that error and check the solutions in Google. I'm not at, I didn't come across this problem so far.
Okay. Even Google can't give me, I tried it, but I cannot get an answer.
Okay, fine. So do you attend the sessions only online or do you happen to?
No, I'll come tomorrow, sir, for this.
Okay, no problem. Just come down, we'll see it.
Okay.
Yeah.
Thank you.
So, okay, guys. Thanks for joining. We'll meet again tomorrow at 2 p.m.